everybody! Welcome back to my apartment. Kristen here, talking to you about some polynomials. Whoop whoop! Alright, but this video we're going to do dividing polynomials by monomials. I almost forgot the words. What am I even doing? Okay, so first we're going to start out with, let's see, my polynomial will be 4x squared plus, let's call it 6x minus 10. Okay? Yeah. So now, actually I want to make this 3, 2, and an x. Alright, so I'm going to divide this off by 2x. So here's my polynomial and my monomial. Remember, mon just being 1, so it's just one little term there. Alright, so to divide this, I'm going to break it down into sections. So pay close attention. Very close. Alright, so what I'm going to do is, this is its own little special thing. I'm going to take it under here, I'm going to take it under here, and I'm going to take it under here. So when I write it out, it'll look like 4x cubed divided by 2x plus, because here's a plus sign, 6x squared divided by 2x minus, because here's a minus sign, so we got to pay attention to the signs, so the signs don't change, minus 10x divided by 2x. Okay? Now if I look at this, it's kind of like going back to the combining like terms. Kind of. 4 divided by 2 is 2, right? So I've got a 2. I can cross those out. Now when you're dividing, remember when you multiply that you add them. So if I had x cubed times x to the second, remember parentheses means times 2, I would actually have x to the third plus 2 equals 5. When I divide them, it's subtracting. So over here, so I've got x to the third divided by x is the same thing as saying x 3 minus 1 equals 2. Because remember, there's a little imaginary 1 there. Even though we don't see it all the time, it's assumed. A lot of things are assumed in math. So, I take 3 minus my imaginary 1, and that gives me 2. So then I write x, 2. Okay? Plus, my plus sign stays the same. I'll switch up colors again. 6 divided by 2 is 3. Alright, so those are gone. And now I've got 2, and there's that imaginary 1 here. 2 minus 1 is 1. So x. So all these are gone, and all these are gone. And now we get to our last one, and my minus sign just comes down, and my plus sign comes down. It's an arrow. Now I'm looking at this, and I've got 10 divided by 2, which is 5. And now x1, because this is a 1, minus x1, well 1 minus 1 is 0, so there is no x. So the final is that right there. That's my answer. So I divided, so this big thing up here that looked all crazy just came down to this. Alright? Oh, I'm short, I can't reach all the way over there. I should move the board. Okay, so now I'm going to bump this up a little bit, because what I like to tell my class is in math you learn the basic, and then you just bump it up. Like you add higher numbers, you add more variables, you add, I don't know, pizza. Okay, so I'm going to use an equation in the book so I don't mess it up. So I've got 6x squared y cubed, so 6x squared y cubed plus 4x cubed y squared, 4x cubed y squared minus 10xy. And this whole thing is divided by 2xy. Okay. So again, I'm just going to take each set, like right here's a little set, and right here's a little set, and right here's a little set, and divide everything by the same number, the same denominator here. So I've got 6x squared y cubed divided by 2xy plus 4x cubed y squared divided by 2xy minus 10xy divided by 2xy. Okay. Flip. Alright, so see the denominator never changed. And the numerator, I just took this apart. Because everything's over the same number, I can put it under each individual one and it's still the same problem. As long as I don't change any of the numbers or the signs. So again, so I've got a plus here and a plus here, a minus here and a minus here. Alright? So I go back, again, like terms. So I've got 6 divided by 2 is 3. So now I have two variables. Not a big deal. They treat each other separately. So I just do the x's first. So I've got x squared over y. Or I'm sorry, x squared over just 1x. 2 minus 1 is 1. So now the x's are done. Now I go to the y's. So here's my y's. I have y cubed, so the third, minus y to the first power. So 3 minus 1 is 2. Y squared. Alright, this whole thing's done now. I don't even got to worry about it ever again. Next, 4 divided by 2 is 2. X cubed, there's my third, x cubed, and x1. 3 minus 1 is 2, so now I have x squared. These are done, and these are done, and that's done. So now I've got my y's. Y squared minus y to the first is just 1. So y minus, there's my minus sign. You always want to double check our minus signs because they're tricky. They'll sneak up on you. Alright, so I've got 10 divided by 2 is 5. Alright, x divided by x is 0 because it's 1 minus 1, and 1 minus 1 is 0. Same thing with y. Y to the first power divided by y to the first power is 1 minus 1, 0. My final answer. Yay! Okay, so notice I did the second problem the exact same way as the first problem, even though I threw in a bunch of more variables. Alright, but it was the same process. So we just took that basic step and we bumped it up a little bit. Remember, with any of these videos, you can always stop, rewind. You can replace anything, any number, any variable with a different number, just trying to make it harder on yourself, because with math, practice, practice, practice. Alright? Practice. It's a shame, but I know sometimes you like doing homework secretly. It's a secret, but I won't tell anybody. Okay. So next, I don't want to do any more of those. What are we at? We're at 8 minutes. Alright, I want to factoring formulas. Yeah! Okay. Factoring formulas. So before we took a binomial times a binomial, right? Well, sometimes you have to go the other way. Alright? Just like I took 4 squared equals, or is the same as 4 times 4, and I had 2 x's, so I had x times x is the same as x squared. Sometimes with the binomials, you have to go back and forth. Actually, with anything, you have to go back and forth, not just the binomials. But that's what we'll start with. Alright, so I've got x squared minus y squared. Now this is the actual formula, so this would work with any number. Is the same as x plus y, x minus y. You might want to know why. Why and why? Hilarious. Alright, but I'm going to prove it to you right now. Okay, so if I distribute my x, just like we did before in the other videos, I've got x squared minus xy. Because x and y, when you multiply them by each other, they don't change. They're just kind of put together. Because I don't know what x is and I don't know what y is. And in any kind of situation where you have an x and a y, ultimately, you're trying to figure out what that x or y or whatever letter that you want to use is representing. Because it's representing some kind of unknown number and you're trying to find it. Okay? So, continuing on. So I've got my x and my y. I've got my minus sign because I had a negative sign right here, right? So now I'm going to do the same thing with my second coefficient. So I've got plus yx minus y squared. Now, just because it's yx instead of xy doesn't mean anything. It doesn't mean it's nada. You can write it any way, as long as it doesn't actually change what it represents, and it doesn't. Okay? So I've got my x squared, because I'm going to combine like terms. That one's gone. Now I've got a minus xy and a plus yx. Again, like I just said, it doesn't matter which direction they go in. This is the same as x times y and y times x, and flip it and flop it and blah, 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 blah. Alright? So then I just look at the numbers in front of it. A negative imaginary 1 and a positive imaginary 1. So minus 1 plus 1 is 0. So they cancel out. It doesn't matter that they're flip-flopped anyway. Okay, so then I've got my negative y squared. Y squared. Now I've got, bringing this down, bring it on down, I've got x squared minus y squared equals x squared minus y squared. Ta-da! I need some like shiny gloves or something. Wouldn't that be fun? I need to write that down. Okay, so I proved that one. So this is our difference of two squares formula. Now, and I say formula again because I can turn this into any set of numbers. So watch what I do. So if I've got 25r squared, so 25r squared minus 49t squared, yep, that looks like a good option. Okay, I can break this down. So if I look at just my coefficients to start with, I've got my r and a t. So it's just like before when I had my x and a y. And remember, it was r squared, rt, t squared. Okay, that's how it looked like before, right? Right. When this wasn't squared. Yeah, okay, that's it. Now, looking at my sign, now difference of squares means I'm going to have one plus and one minus, because that's what it takes to get those middle coefficients to go away. So I already know, in a different color, that this is going to be a plus, and this is, wait, that's not a plus, and this is going to be a minus. And I can put these